All right. Imagine you're standing by a serene pond. The water's surface is smooth as glass. You're about to toss a few pebbles into it, creating ripples that will dance across the stillness. Throw one pebble and watch as it breaks the surface. You get ripples expanding outwards in perfect concentric circles. Each circle is a wave, carrying energy away from the point of impact. Now throw two pebbles side by side, not too far apart. Watch closely, and you'll see something interesting happen. The ripples from each pebble begin to interact with each other. Sometimes, when the crests of two ripples meet, they boost each other, creating a larger wave. This is called constructive interference, where the waves reinforce each other, but sometimes they cancel out. When the crest of one ripple meets the trough of another, they neutralize each other, leaving the water surface flat. This is destructive interference, creating areas of calm amidst the waves. This simple demonstration, believe it or not, is the perfect way to picture one of the weirdest and most profound experiments in all of physics. It's a cornerstone of our understanding of the quantum world. It's called the double slit experiment. Here's how it works in its most basic form. We'll walk through the setup and the mind-bending results. Take a screen and shine a beam of light at it, like a flashlight or even a laser pointer. The light will illuminate the screen, creating a bright spot. But now, block the light with a barrier. This barrier has two narrow slits cut into it, side by side. These slits are the key to the experiment. On the other side of the barrier, you place another screen. This screen will act as a detector, catching the light that manages to pass through those slits. This screen will allow us to see what happens to the light after it goes through those slits. It's like a canvas for the light to paint its picture. Now, let's think about what we expect to see. If light were just a stream of tiny particles, like tiny bullets being fired from a machine gun, you'd expect to see two bright spots on the screen directly behind each slit. One spot for each stream of particles that made it through. Simple, right? But that's not what happens at all. Instead of two distinct spots, you get a pattern of stripes on the screen, alternating bright and dark bands like a zebra crossing. This is what's called an interference pattern. It's a signature of wave behavior. It's the exact same pattern you get when two sets of ripples meet and interfere with each other on the surface of water, just like our pebbles in the pond. This tells us that light, in some way, acts like a wave, spreading out and interfering with itself as it passes through the slits. But here's where things get seriously odd, and where the quantum weirdness really begins to kick in. Scientists, being curious, decided to take this experiment a step further. Instead of firing a continuous stream of light, they tried firing just one photon at a time, a single solitary particle of light through the slits. You'd think, all right, if we're sending photons one by one, each photon has to go through either one slit or the other. There's no way it can split itself. But after you let enough photons go through one at a time and patiently wait for them to accumulate on the screen, the same interference pattern appears. The stripes emerge, even though each photon went through individually. It's as if each individual photon is somehow interfering with itself, even though there's nothing else around for it to interfere with. It's behaving as if it's going through both slits at once, even though it's just a single particle. Now, to make things even stranger, if you try to peek and see which slit the photon actually goes through by placing a detector at one of the slits, everything changes dramatically. The act of observation alters the outcome. The delicate interference pattern, the stripes, completely disappears. Instead of the interference pattern, you're left with just two simple spots on the screen, exactly what you'd expect if light were behaving like a stream of little particles going through one slit or the other. It's as if the photon somehow knows it's being watched, that its path is being observed, and decides to play by different rules, switching from wave-like behavior to particle-like behavior simply because we're looking. This isn't just some weird magic trick or a quirky observation with no real-world relevance. The double slit experiment is at the very heart of quantum mechanics, the theory that governs the behavior of matter and energy at the atomic and subatomic levels. It raises profound questions about the nature of reality itself, forcing us to reconsider our fundamental assumptions about how the universe works. How can something like a photon act both like a wave, spread out and interfering, and a particle, a localized point of energy? And perhaps even more puzzling, why does the act of observing the photon change the outcome of the experiment? What does it mean for consciousness and its role in shaping reality? Even today, with all our scientific advancements, there's no single, universally accepted, simple answer to these questions. The double slit experiment continues to challenge our understanding of the universe. So next time you flip on a light switch and the room is illuminated, remember the strange and wonderful world of quantum mechanics. Down at the tiniest scales, the universe plays by rules that often sound more like magic or science fiction than the everyday science we're familiar with. The double slit experiment serves as a constant reminder to me and to scientists around the world that the world is far stranger, far more complex, and ultimately far more wonderful than we could ever have imagined. It's a universe filled with mysteries waiting to be unraveled.
If you guys liked our video and you want to help us out, you want to support us, please consider clicking on our affiliate link for InVideo AI, which is the program that we use to create these videos. It's a really helpful tool for someone with no experience to produce a high quality video. You can use natural language and just write in kind of what you're looking for, and it usually nails it. And if it doesn't, you can go back, change the music on each chapter, change every single video clip into a different clip. You can use both generative AI, so it'll produce totally new and fresh animation for you, or you can use stock footage. You can change the narrator's voice for the entire video with just a natural language prompt. Look at specific clips and change each one. You can change the music using the same technique, either just a whole approach with natural language, or you can go in and specifically edit out each. The real value that we found with InVideo is just that we don't have any experience necessarily with video editing, but we were able to put together some stuff that we really enjoyed. It was good enough that we wanted to put it out on the internet for you guys. And we're looking forward to using InVideo moving forward, seeing what we can do in the future. If you like our video, you like our content, and you would like to support us, please consider clicking our affiliate link and trying out an InVideo subscription, and you can produce the same type of quality work with just as little experience as we have.